In this video, we are going to talk about some questions under pa- rational functions. So now we have express 3 divided by x cubed plus 1 as a partial fraction. How do we do this? Now, you see this x cubed plus 1. X cubed plus 1 can also be written as 1 plus x times 1 minus x plus x squared. Now let's do this multiplication and see whether we'll get back our x cubed plus 1. So 1 times all of this will give you 1 minus x plus x squared. Then x times 1 is plus x. Then x times minus x is minus x squared. Then x times x cubed is plus x. X times x squared becomes plus x cubed. So you can see that minus x plus x can cancel out. Plus x squared minus x squared can cancel out. So we are left with x cubed plus 1. So now, because x cubed plus 1 can be expressed as this, then this rational function, which is x cubed plus 1, is now equal to 3 divided by x cubed plus 1 is now equal to 3 divided by into bracket 1 plus x times into bracket 1 minus x 1 minus x. Let me rewrite it here. So 3 divided by x cubed plus 1 can be written as 3 divided by into bracket 1 plus x times another bracket 1 minus x plus x squared. So now this is what we will then take and express in partial fractions. So in terms of partial fractions, 3 divided by 1 plus x times 1 minus x squared plus minus x plus x squared is equal to a divided by 1 plus x and plus bx. See, this is a quadratic function, so bx plus c divided by 1 minus x plus x squared. So let's find the LCM. The LCM is 1 plus x, so all of that times 1 minus x plus x squared. Then, so if we put a here, here is 1 plus x, so it will cancel this. So here we multiply 1 minus x plus x squared. Then plus bx plus c, all of that will multiply 1 plus x. And that is equal to 3 divided by 1 plus x times 1 minus x plus x squared. So since the denominators are equal, we can equate the numerators. So it implies that a times 1 minus x plus x squared, then plus into bracket bx plus c, then times 1 plus x is equal to 3. So let's expand the bracket. This becomes a times 1 minus x plus x squared, then plus bx, then bx will multiply 1 plus x, then plus c times 1 plus x equals 3. So continuing further, a times 1 minus x plus x squared, then plus, now b times x times 1 is x, then plus x times x is x squared, then plus c times 1 plus x is equal to 3. So now let's group like terms. You can see that there is an x squared here and there is an x squared here. So it means that a plus b is equal to 0. This implies that a is equal to minus b. So this is our equation 1. And you can see x here. There's also an x here and there's an x here. So minus a, then plus b, and then plus c is equal to 0 because there's no x here. But we know that a is equal to minus b. So it means that minus into bracket minus b plus c is equal to 0. So this means that 2b plus c is equal to 0. Now, you can see that this one has got no x, and then C2 has also got no x. So A plus C is equal to 3. Now, from here, we can make, but we know that A is equal to minus B. So, in other words, minus B plus C is equal to 3. So, this becomes our equation 2. Sorry, 3. And then this becomes our equation 2. Now, from this equation, let me write equation 2 down here. We have 2B then plus C is equal to 0. So this is equation 2. Equation 3 from equation, in other words, we can subtract equation 2 minus equation 3. So this becomes 2B minus B. Minus B becomes 3B. And that is equal to, the C will go to 0. 0 minus 3. So in other words, let me continue from here. 3B is equal to minus 3. So B is equal to minus 1. Now that we have gotten B, we know that A is equal to minus B from equation 1. So it means that A is equal to 1. And then from equation 3, we know that A plus C is equal to 3. So A is 1. 1 plus C is equal to 3. And therefore C is equal to 2. So A is equal to 1, B is minus 1, and then C is 2. So this, in terms of partial fractions, let me write it here, which is 3 divided by x cubed plus 1 is equal to A. We got A as 1, so 1 divided by 1 plus x, then plus bx. B is minus 1, and then C is 2. So let me write C first. So C is 2, and then B is minus 1. So minus 1 times x is minus x. So minus x divided by 1 minus x plus x squared. So this is the correct answer for this question in partial fractions. So now we are supposed to express 4x squared divided by x plus 1 times x minus 1 as a partial fraction. Now, if you look at x plus 1 times x minus 1, this is difference of two squares. It becomes x squared minus 1. So the highest power of x in the numerator is squared, and the highest power of x in the denominator is also exponent 2. So the powers are equal, and because the powers are equal, you are supposed to divide to get first a constant. So if you divide x squared plus x squared, you are going to get a constant, and therefore 4x squared divided by x plus 1 then times x minus 1 expressed as a partial fraction is going to give us a certain constant a, and plus another constant b divided by x plus 1, and plus another constant c divided by x minus 1. So let's find the LCM here. The LCM is x plus 1 times x minus 1. So a is going to multiply x plus 1 then times x minus 1, and plus b, yes, x plus 1, so b will multiply x minus 1 then plus c, yes, x minus 1, so c will multiply x plus 1. Now this is equal to 4x squared divided by, into bracket, x plus 1 then times x minus 1. So now, since the denominators are equal, we can equate the numerators. So a, x plus 1 then times x minus 1 plus b times x minus 1 and plus c times x plus 1 is equal to 4x squared. Now, if we further simplify this, this is a times x squared minus 1 then plus b times x minus 1 and plus c times x plus 1 is equal to 4x squared. Now, so from here we can write our system of linear equations and solve them simultaneously. So you can see that there is an x squared here, and apart from here there's no other x squared. So ax squared is equal to 4x squared, and therefore outrightly we see that a is equal to 4. Then now we also have x here, and then we have x here. So b plus c is equal to 0. It implies that b is equal to minus c. So this is equation 1. Then now, apart from that, we have minus 1 here. So minus a, and then we also have minus here, minus b, and then we have plus 1 here. So plus c is equal to 0. But we know that a is equal to 4, and then b is equal to minus c. So minus 4 minus c plus c is equal to 0. So it implies that now minus c becomes plus c. So c plus c is 2c is equal to 4. Therefore c is equal to 2. So since c is equal to 2, we know that b is equal to minus c. Therefore b is equal to minus 2. So in the end, we have a equals 4, b equals minus 2, and then c is equal to 2. So therefore, this expressed as a partial fraction. Let me write the final answer here. So 4x squared divided by 2 bracket x plus 1 then times x minus 1 is equal to a. A is 4, then plus b. However, b is minus 2, so minus 2 divided by x plus 1, then plus c, which is 2, so 2 divided by x minus 1. Sketch the curve f of x equals 4 times into bracket x minus 1 divided by x minus 2 all squared. So how do we sketch this curve? The first thing is to find the vertical asymptote. So now, the vertical asymptote, if we equate this to 0, you find out that x equals 2 will make this function undefined. So we have a vertical asymptote at x equals 2. Then the next thing we are supposed to do is to find the zeros of this function. So that is to equate x minus 1 to 0. Therefore, you see that x equals 1 is one of the zeros of this function. So there is a turning point at 1 and then 0. So now let's sketch the function. So let's sketch the vertical asymptote. So this is a vertical asymptote at x equals 2. Now, we have zeros at 1 and 0. So there is a turning point here. So there is a turning point at 1 and 0. Now let's find the nature of the graph in the various regions. So let's take values greater than 2. So let's find f of 3. What is f of 3? So now, if we find f of 3, this is equal to 4 times x 3 minus 1 divided by 3 minus 2 squared. So now 3 minus 1 will give us a positive answer. Sorry, 3 minus 1 is a positive number, times 4 will still give us a positive number. Divided by 3 minus 2 is also a positive number. Squared will also give us a positive number. And therefore, so the final result is a positive number. So as x approaches infinity, then f of x also approaches infinity. The next thing is to also find the nature of the graph in this region. So let's find the nature of the graph at values less than 2. So let's find the nature of the graph in this region. So let's take like 1.5. So what is f of 1.5? So this is equal to 4 times 1.5 minus 1 divided by 1.5 minus 2 squared. So you see that 1.5 minus 1 is a positive number, times 4 is still a positive number, divided by 1.5 minus 2 is a negative number. If you square, you get a positive number. So it means that as x approaches 2 on this side, f of x approaches infinity. So now, if we were to sketch the graph here, the graph will look like this. And then now, in this region, the graph will also look like this. Remember that 1 is a turning point. Now let's find values below 1, like f of 0. So let's find f of 0 and see the nature of the curve. Now if you put 0 in this, you are going to get a negative value. And then negative value divided by 0 minus 2 is minus 2. When you square it, you get a positive value. So the final result will be a negative value. So what it means is that as x approaches this turning point, the graph of f of x goes to negative infinity. So therefore, this curve is going to look like this. Express x cubed plus x squared minus 2x plus 4 divided by x squared minus 4 as partial fractions. The first thing to notice is that this is an improper fraction, because the highest power in the numerator is x cubed and the highest power in the denominator is x squared. So if you find the difference is an x. So this implies that x cubed plus x squared minus 2x plus 4 divided by, now x squared minus 4 is difference of two squares. It can be written as x plus 2 times x minus 2 is equal to, remember the difference is 1, so ax plus a constant b, then plus another constant c divided by x plus 2, then plus another constant d divided by x minus 2. So if you find the LCM, here's x plus 2 n times x minus 2. So ax is going to multiply x plus 2 times x minus 2, which is the same as x squared minus 4. Then plus b will also multiply x squared minus 4. Then plus c will multiply, here's x plus 2, so here will be x minus 2. Then plus d will multiply, here's x minus 2, so to multiply x plus 2. Now this is equal to x cubed plus x squared minus 2x plus 4 divided by x plus 2 and times x minus 2. Now, since the denominators are equal, that means that we can equate the numerators. So we have ax times x squared minus 4 and plus b times x squared minus 4 then plus c times x minus 2 then plus d times x plus 2. This is equal to x cubed plus x squared minus 2x plus 4. So now what we'll do is that let's rewrite this as a times x squared is x cubed, then x times minus 4 is minus 4x, then plus b times x squared minus 4, then plus c times x minus 2, and plus d times x plus 2. All of this is equal to x cubed plus x squared minus 2x plus 4. So now you can see that on the left hand side of the equation we don't have any x cubed except this. So the coefficient of x cubed here too is 1. So a is equal to 1. Now again on this side we don't have any other place where we have x squared apart from bx squared. The coefficient of x squared here is also 1, so it implies that b is also equal to 1. Having established this, you can then go about and say there's an x here, there's one here, and there's another here. So minus 4a and then plus c, and there's also an x here plus d, because the coefficient of x here is minus 2. But we know that a is 1, so minus 4 times 1 plus c plus d is equal to minus 2. So c plus d is equal to minus 2 plus 4, which is the same as 2. So this is equation 1. Now, you can see that those without x, this one has no x, this and that. So we have minus 4b, then minus 2c plus 2d equals 4. Now, b is equal to 1, so it means that minus 2c plus 2d is equal to 4, then plus 4 times 1. So minus 2c plus 2d is equal to 8. So this is equation 2. Now let's multiply equation 1 by 2. So we have 2c plus 2d is equal to 4. So this is equation 3. If we add equation 3 and equation 2, we see that 4d is equal to 12, and therefore d is equal to 3. But we know that c plus d is equal to 2 from equation 1. So c plus 3 is equal to 2, and therefore c is equal to minus 1. So a is equal to 1, b is equal to 1, c is equal to minus 1. Sorry, here's c. C is equal to minus 1, and then d is equal to 3. And therefore, in rewriting this as a partial fraction, let me write it here. S cubed plus x squared minus 2x plus 4 divided by x squared minus 4 is equal to a, which is 1. Sorry, a times x, which is 1 times x, which is x. Then plus b, b is 1. Then c is minus 1, so minus 1 divided by x, plus c is divided by x plus 2, so plus 2. Then d is 3, so plus 3 divided by x minus 2. Sketch the curve f of x equals 4 times into bracket x plus 1 squared divided by 2 times into bracket x plus 2 and times into bracket x minus 2. So now let's find the vertical asymptote. So you see here is 2 and here is minus 2. It means that we have vertical asymptote at x equals 2 for this, and then x equals minus 2 for this one. Apart from this, let's find the zeros of this function. X plus 1 equals 0. Therefore, x is equal to minus 1. So we have zeros at minus 1 and then 0. We have a turning point at minus 1 and 0. And the next thing is to find the horizontal asymptote. You can see that if we square, here will carry the power of x squared. And this one too, if we multiply, it also carries the power of x squared. And therefore, the horizontal asymptote is just going to be 4 divided by 2, which is equal to 2. So we have horizontal asymptotes at y equals 2. So having got this, then let's go ahead and sketch the curve. So we have vertical asymptotes. Let's assume here is 2. So we have vertical asymptote at x equals 2 and x equals minus 2. And we have horizontal asymptote at y equals 2. So this will be our horizontal asymptote. And then this is our vertical asymptote. So now let's find the nature of the graph in the various regions. Let's take values greater than 2. For example, what is f of 3? So you see that if we put 3 here, 3 plus 1 is a positive number. If we square it, we still get a positive number. If we multiply by a positive number, the numerator is a positive number. Now, 3 plus 2 is a positive number. And 3 minus 2 is still a positive number. Positive number times a positive number is a positive number. Therefore, it's positive number divided by a positive number, which is equal to a positive number. So it means that as x approaches infinity, f of x also approaches infinity. And therefore, the nature of the curve here is going to look like this. Let's check this region. Let's look for the nature of the curve as x approaches 2. So now let's take a value like, let's find f of 1. So if you put 1 here, 1 plus 1 will give you a positive number. If you square it, you get a positive number. Divided by 1 plus 2 is also a positive number. However, 1 minus 2 is a negative number. Positive number times negative number is a negative number. So the result is equal to a negative number. So as x approaches 2, then f of x. So as x approaches 2, f of x approaches minus infinity. Now let's check as x approaches minus 2. So let's find f of, let me do it here. Let's find f of minus 1. So if you put minus 1 here, minus 1 plus 1 is a positive number. If you square a positive number, you still get a positive number. Divided by, now if you put 1 here, 1 plus 2 is a positive number. Nonetheless, 1 minus 2 is a negative number. Positive number times a negative number is a negative number. So the result is a negative number. So what it means is that as x approaches minus 2, f of x approaches minus infinity. What is the y-intercept? The y-intercept is just to find x of 0. That is f of 0. So f of 0, what will it give us? So if we put 0 here, we are going to get 0 plus 1 is 1. 1 squared is 1. 1 times 4 is 4. So 4 divided by 2 times 0 plus 2 is 2. Then 0 plus 0 minus 2 is minus 2. 2 times minus 2 is minus 4. So 2 times minus 4. So at the end of the day, we are going to get f of 0 as minus 1 over 2. So the y-intercept is somewhere here. Minus, let's assume here is minus 1 over 2. So here's our y-intercept. However, we have a turning point at minus 1 and 0. So assume here is minus 1. So here's the turning point. So the nature of the curve will look like this. So this is the nature of the curve in this region. Then apart from that, let's check the nature of the curve in this region. Let's find f of minus 3. So if we put minus 3 here, minus 3 plus 1 is minus 2. If you square it, you get a positive number. Divided by minus 3 plus 2 will give a negative number. And minus 3 minus 2 also give a negative number. Negative number times negative number is a positive number. So the result is a positive number. So what it means is that as x, so let me write it down here, as x approaches minus infinity, f of x approaches infinity. And therefore, the nature of the curve in this region is also going to look like this. So this is how this curve looks like. Sketch the curve g of x equals 3x plus 2x minus x squared divided by x squared plus 7x plus 6. Now, what we need to do is that we need to factorize both the numerator and the denominator. So g of x can also be written as, now 3 times minus 1 is minus 3. So two numbers that when we multiply, you get minus 3, but when you add, you get plus 2. That is 3 and minus 1. Sorry, there is no x here. This is a mistake. This becomes, g of x becomes 3 and then plus 3x minus x squared divided by x squared. Now, two numbers that when you multiply, you get 6, but when you add, you get 7. So it is 1 and 6. So x squared plus x plus 6x plus 6. So g of x is equal to, if you factorize 3 here, you get 3 times 1 plus x. Then if you factorize minus x here, you get 1 plus x divided by, now you can factorize x here, get 1 plus x. And when you factorize 6 here, you also get 1 plus x. So at the end of the day, g of x can be written as 3 minus x, then times 1 plus x, and divided by x plus 6, divided by times 1 plus x. So this 1 plus x and 1 plus x can cancel out, and therefore g of x can be written as 3 minus x divided by x plus 6. What this means is that the graph contains a hole, or the graph is discontinuous at x equals minus 1. So let's go ahead and sketch this curve. Nonetheless, let's find the vertical asymptote. So we know that there's a vertical asymptote at x equals minus 6. And then for the zeros, we have a turning point at 3 and then 0. Now, because the highest power of x here is 1 and the highest power of x here is also 1, you can see that we have a horizontal asymptote at y equals minus 1. So let's go ahead and sketch this curve. A vertical asymptote at x equals minus 6. So let's assume here is minus 6. So there's a vertical asymptote over here. And then apart from that, we have a turning point at 3 and 0. So let's assume here is 3. So there's a turning point here. And then we have a horizontal asymptote at minus 1. So here's minus 1. This is the horizontal asymptote. So we have a horizontal asymptote here. Now, let's look at the nature of the curve in the various regions. So let's check in this region what will be the nature of the curve. So we need to find values as x approaches minus infinity. So let's find g of minus 7. So if you put minus 7 here, 3 minus minus 7 will give us a positive number. And then minus 7 plus 6 will give us a negative number. Sorry, a negative number. So the result is a negative number. So what it means is that as x approaches minus infinity, g of x also approaches minus infinity. So the nature of the curve in this region will look like this. Now let's come to the region beyond the turning point, which is x equals 3. So let's take a value like g of 4. Now if you put 4 here, 3 minus 4 is minus 1, so it's a negative number. And then 4 plus 6 is 10, that's a positive number. So the result is a negative number. So for the region that is as x approaches infinity, g of x approaches minus infinity. Nonetheless, remember that we said that there is a hole in this graph at x equals 1. Sorry, x equals minus 1. So assuming here is minus 1, there is a hole in this graph at this point. Then now, let's also find the region less than 3. So let's find g of 0. Now, if you put 0 here, 3 minus 0 is positive number. And then 0 plus 6 is also a positive number. So the result is positive number. So the nature of the graph here is it's going to infinity as x approaches 3. Now let's check what is the nature of the graph in this region, which is between minus 1 and minus 6. So let's take a value like g of minus 2. So 3 minus minus 2 will give us a positive number, divided by minus 2 plus 6 is also a positive number. So therefore, the result is a positive number. So we are going to, this means that as x approaches minus 6, g of x approaches infinity. So the nature of the curve is going to look like this. So then here look like this. But beyond 3, the graph goes to the negative infinity. So this is the nature of the curve. Express x squared divided by x minus 3 times x plus 4 as a partial fraction. So now you can see that x times x is x squared. So since the powers on the numerator are equal to the powers in the denominator, then we can rewrite this x squared divided by x minus 3 times x plus 4 as equal to a certain constant, which is a, plus b divided by x minus 3 and plus c divided by x plus 4. So if we find the LCM, it's x minus 3 times x plus 4. So A is going to multiply x minus 3 then times x plus 4. Then plus B, yes, x minus 3. So B will multiply x plus 4. Then plus C. C will multiply x minus 3. So this is equal to x squared divided by x minus 3 times x plus 4. So this implies that A times x minus 3 times x plus 4 and plus B times x plus 4 plus C times x minus 3 is equal to x squared. So A times x is x squared. Minus 3x plus 4x becomes plus x. Then minus 12 plus B times x plus 4. Then plus C times x minus 3 is equal to x squared. So here's x squared. So ax squared, there's no other x squared anywhere. So the coefficient of x squared here is 1. So therefore A is equal to 1. Then now we have ax, sorry, there's an x here, there's an x here, and then there's an x here. So therefore A plus B plus C is equal to 0. But we know that A is equal to 1. So this implies that B plus C is equal to minus 1. So this is our equation 1. Then now here's minus 12. So minus 12A. Then here's 4B. So plus 4B. Then minus 3C is equal to 0. Now A is equal to 1. And therefore 4B minus 3C is equal to 0 plus 12. And that's equal to 12. So now let's multiply. So this is equation 2. Let's multiply equation 1 by 3. So 3b plus 3c is equal to minus 3. So if we add the 2, so 7b is equal to 9. And therefore b is equal to 9 over 7. But we know that b plus c is minus 1. So c is equal to minus 1 minus b. Therefore c is equal to minus 1 minus 9 over 7. Therefore c is equal to minus 16 over 7. Now, having gotten the value of c, then we know that a is 1, b is equal to 9 over 7, and c is minus 16 over 7. And therefore, x squared divided by x minus 3 times x plus 4 is equal to a is 1, then plus b divided by b is 9 over 7. So 9 divided by 7 times x minus 3. Then minus c. So minus 16 divided by 7 times x plus 4. So this is our answer. Express 2x minus 7 divided by x minus 5 squared as a partial fraction. So now this is the case of repeated roots. So this is 2x minus 7 divided by x minus 5 squared. This can be written as equal to a divided by x minus 5 and plus b divided by x minus 5 squared. So if we do the LCM is x minus 5 squared. So a is going to multiply x minus, let's say squared here, minus 5, and b will multiply 1. Then this is equal to 2x minus 7 divided by x minus 5 squared. So equating the numerators, a times x minus 5 plus b is equal to 2x minus 7. So now we can see that from here outrightly a is equal to 2. Then now minus 5a plus b is equal to minus 7. So if a is equal to 2, we have minus 5 times 2 plus b is equal to minus 7. So b is equal to minus 7 plus 10. Therefore b is equal to 3. So what it means is that a is 2 and b is 3. So 2x minus 7 divided by x minus 5 squared as a partial fraction is a, which is 2, divided by x minus 5, then plus b, and b is 3, so plus 3 divided by x minus 5 squared. Let's express minus 6x squared plus x minus 12 divided by into bracket 5x plus 2x squared times into bracket x plus 3 as a partial fraction. So let's rewrite this as minus 6x squared plus x minus 12 divided by 5x plus 2x squared, then times x plus 3. This can be written as ax plus b, because this is a quadratic function. So ax plus b divided by 5x plus 2x squared, and plus c divided by x plus 3. So if you find the LCM, here is going to give us 5x plus 2x squared, then times x plus 3. So here is ax plus b, and times, so ax plus b is going to multiply x plus 3, and plus c times 5x plus 2x squared. So this is equal to minus 6x squared plus x minus 12 divided by 5x plus 2x squared, then times x plus 3. So this implies that ax plus b, then times x plus 3 plus c 5x plus 2x squared is equal to minus 6x squared and plus x minus 12. Now let's expand this. Ax times x plus 3 will multiply plus b, then x plus 3, then plus c times 5x plus 2x squared equals minus 6x squared plus x minus 12. So now this can also be written as a times x is x squared plus x times 3 is 3x, and plus b times x plus 3, and plus c times 5x plus 2x squared, then equals minus 6x squared plus x minus 12. So now what it means is that here's x squared and here's x squared. So a plus 2c, then here's x squared equals minus 6. So this is our equation 1. Then here's x, here's also x, and here's x. So 3a, and then plus b, and then here's 5c, so plus 5c is equal to coefficient of x is 1. So this is equation 2. And then the last thing is this b, so 3b, so 3b is equal to minus 12. So it implies that b is equal to minus 4. But we know that from equation 2, 3a plus b plus c is equal to 1. So in other words, 3a minus 4 plus 5c is equal to 1. 3a plus 5c equals 5 is equation 3. Then let's write equation 1 beneath it. However, let's multiply equation 1 by 3. So that will be 3a plus 6c is equal to minus 18. So this is equation 4. Now let's subtract equation 3 from equation 4. So 3a minus 3 is 0. So 60 minus 5cc equals minus 18 minus 5 is going to give us minus 23. So c is equal to minus 23. Nonetheless, we know that a plus 2c is equal to minus 6. So a plus 2 times minus 23 is equal to minus 6. So a is equal to minus 6 minus 2 times minus 23 is minus 46. So a times is equal to minus 6 plus 46. So a is equal to 40. So a is 40, b is minus 23, and then c is 4. So what it means is that minus 6x squared plus x minus 12 divided by 5x plus 2x squared. Then all of that times x plus 3 can be written as a. A is 40, so 40x. Then plus b. B in our case was minus 4, so 40x minus 4 divided by 5x plus 2x squared. And then plus c. C in our case was minus 23, so minus 23 divided by x plus 3. Express f of x equals 9 minus 3x minus 12x squared divided by into bracket 1 minus x times into bracket 1 plus 2x as a partial fraction. So now, let's rewrite this as 9 minus 3x minus 12x squared divided by 1 minus x into bracket times 1 plus 2x. This can be rewritten as a divided by 1 minus x and plus b divided by, sorry, I made a mistake. If you check here, the highest power here is x squared, and then the highest power here, x times x, is also x squared. And therefore, we are going to have a certain constant plus the rest. So this is going to give us a plus b divided by, so a plus b divided by 1 minus x and plus c divided by 1 plus 2x. So if you find the LCM, I'm going to get 1 minus x here and then 1 plus 2x here. So a will multiply 1 minus x then times 1 plus 2x and plus b times, here's 1 minus x, so it will cancel this, so it will be 1 plus 2x and plus c times, here's 1 plus 2x, so c will multiply 1 minus x. So this is equal to 9 minus 3x minus 12x squared divided by 1 minus x then times 1 plus 2x. So now, since the denominators are equal, we can equate the numerators. So therefore, 1a times 1 minus x times 1 plus 2x and plus b times 1 plus 2x and plus c times 1 minus x is equal to 9 minus 3x minus 12x squared. So let's rewrite this as a times, now 1 times 1 is 1, and then 1 times 2x is 2x. 1 times minus x is minus 2 minus x. So 2x minus x is going to give us plus x. Then minus x times 2x is going to give us minus 2x squared. Then plus b times 1 plus 2x. Then plus c times 1 minus x equals 9 minus 3x minus 12x squared. So you can see that there is an x squared here and there is none any other place. So minus 2a is equal to minus 12, and therefore a is equal to 6. Now this is an x, this is an x, and this is an x. So it means that a and then plus 2b then minus c is equal to, the coefficient of x here is minus 3. But we know that a is equal to 6. So it implies that 2b minus c is equal to minus 3 minus 6. That will give us minus 9. So this is equation 1. And also here has not got any x. This has not got any x. Neither has here got an x. So it means that a plus b plus c is equal to 9. But we know that a is equal to 6. So it implies that b plus c is equal to 9 minus 6, which is equal to 3. So now, here's equation 2. So let's multiply equation 2 by 2. So if we multiply equation 2 by 2, we can write it here. That will be 2b then plus 2c is equal to 2 times 3 is 6. So let's subtract. So here becomes our equation 3. Let's subtract equation 1 from equation 3. So that's equation 3 minus equation 1. So the b's will go to 0. 2c minus c will give us 3c equals 6 minus 19. Sorry, 6 minus 9 is going to give us 15, and therefore c is equal to 5. Now that we've gotten c equals 5, we know that b plus c equals 3. So in other words, b is equal to 3 minus 5, and therefore b is equal to minus 2. So a is 6, c is 5, and b is minus 2. So this implies that 9 minus 3x minus 12x squared divided by into bracket 1 minus x times into bracket 1 plus 2x is equal to a. A in this case is 6, so 6 plus, then b is minus 2, so minus 2, so 6 minus 2 divided by 1 minus x, then c is 5, so plus 5 divided by 1 plus 2x. So this is our final answer.